We question whether the energetic neutral atom ribbon images acquired by IBEX-Hi through remote sensing scans in the Moon's resonant orbit truly originates from the heliopause. This issue involves assessing the scale of solar wind particle energy loss across the entire solar system. ENA imaging simulations at Lagrange points indicates that the volume of planetary magnetospheres at AU scale remote sensing distances is too small to form the ENA ribbon. However, the effective differential flux derived from planetary magnetosphere simulations, which matches the measured peak of the ENA ribbon, provides a reference for evaluating the physical scale of the heliopause's massive magnetic structures. Near Earth's orbit, the ENA differential flux from the ENA emission cone, generated by charge exchange between solar wind ions and local neutral gases, is comparable to the measured peak of the ENA ribbon, suggesting that this may be the primary ENA emission source contributing to the ribbon's peak signal. Two-dimensional ENA imaging measurements at Lagrange points can utilize the time delay and parallax of ENA energy spectra to investigate the origin of the ENA ribbon signal. Unlike photons, ENA particles propagate at finite speeds, so ENA imaging measurements are typically only suitable for relatively nearby emission sources. When the measurement distance extends to AU scales, the spatial and temporal scales of the ENA emission sources must be evaluated to meet the measurement requirements for radiation flux and spectral continuity. Therefore, we raise doubts from both temporal and spatial perspectives regarding the claim that the ENA ribbon originates from the heliopause beyond 120 AU. First, planetary magnetosphere simulations suggest that the geometric scale of the ENA emission wall required to produce the ENA ribbon would span several tens to hundreds of AU. From an energy spectrum perspective, simultaneously detecting ENA particles ranging from 700 electron volts to 4.3 kilo electron volts would require this enormous ENA emission wall to remain stable for approximately 9.3 years. Given that the solar activity cycle lasts 11 years, a heliopause ENA emission wall stable for nearly a full solar cycle would imply an essentially unchanging structure. Consequently, when the Voyager spacecraft crossed the heliopause, it should not have missed such a massive and long-lasting ENA emission structure. Yet, to date, no relevant measurement data have been reported. With the increasing number of in-orbit ENA images, we expect the discovery of more ENA signals originating from plasmoid populations near Earth's orbit.